Clicked the wrong thing, sorry. Okay, factoring. Now we've already started factoring, but I want you to understand something. Factoring is so important, not just in math, okay? I want you to understand the concept of what factoring is. Factoring is the ability to break something down that is very complex into something very manageable, into smaller pieces, things that we can do something about. So think about a world issue. I mean, like world hunger, right? And you want to make a difference with world hunger? If you keep it big, like world hunger, that's pretty big, right? If you keep it that big, an issue like that, you are never going to go anywhere with it. You're never going to make a big solution or a dent in that issue, right? I don't know. I want to solve world hunger. Well, I can't solve world hunger. What were you going to say? I'm sorry. I was right in the middle of the sentence. Sorry. Go ahead.
1,000 miles start with one step.
Right. Exactly. Perfect. 1,000 miles starts with one step. So you've got to take a step, right? If you just stick with the big thing, you're going to be too overwhelmed. Don't you agree with me? Do you agree with me?
Yeah.
Right? So suddenly you start to think, well, what contributes to world hunger? Well, there's a lot of food on the planet, but you know, it's like, I mean, I'm not starving. I have extra. I sometimes throw things away, and I shouldn't. It goes stale in the refrigerator or whatever, right? Right? But if somebody else were here who is starving, I'd give it to him, right? I'd be happy. I mean, before it's spoiled. I mean, you know what I mean? I'd be happy to share it, right?
It's spoiled now.
Yeah, right. Yeah. So clearly, sorry, I am boiling. So clearly, there's a geographical problem, right? I don't know. I don't live in the same place as the person that is hungry, right? I mean, I might. There's some homeless people in Santa Fe. Sure, I could go out of my way and actually do something there. So then I could think, oh, well, there are homeless people in Santa Fe. Okay, so world hunger is actually, well, there's homeless people in Santa Fe. That's one factor. You see what I'm saying? That's one factor of this gigantic problem. Now, I would have a hard time. There's another factor of there's homeless people in Indonesia, right? Now, that one's a little harder for me to deal with because I don't live in Indonesia. Right? So that's a factor that is a little not easy for me to handle. Does that make sense? Right? But this other factor I can deal with. So if I deal with just this little factor that I can deal with, I've actually made a dent in this gigantic problem. Does that make sense? Factoring is the same thing. I will give you complex, crazy-looking stuff, and the idea and the ideal, the goal, is to break it down into smaller pieces so that we can actually do something with it. And you're going to have to take my word for it right now that it will actually be useful. It will actually be something you can actually do. There's stuff you can do once you factor these things down. Right now, all we're going to focus on is factoring, okay? And I've already given you a bunch of tools. The first thing I gave you was factoring out the YMCA. GCF, right? Greatest common factor, right? The greatest common factor. So you know that. That is the cardinal rule. I call that the cardinal rule of factoring. That's the first thing you should always try when you're factoring. First thing. Okay? So let's say I gave you an expression, a trinomial, quadratic trinomial. What does quadratic mean? Does anybody know? How do you know whether something is a quadratic?
Numbers?
Not really. That's because you'd think quad would mean 4, right? But I could give you a quadratic trinomial. So the thing is, how do you know it's a quadratic expression? If it has, instead of x, if it has an x squared in it, it's a quadratic expression.
So an expression with exponents in it?
With x squared in it.
With anything with x squared?
If it has an x squared in it, it's a quadratic.
What
Now,
if it
there's a
has
few
x
exceptions.
cubed?
There's a few exceptions because there's circles and there's other shapes too that have x squareds in it. But those have y squareds as well. Let's say it has x. So if I wrote this, y is equal to x, is that a straight line or a quadratic? It's a straight line, right? That's y equals mx plus b. What's m? Right, which is what on this? What's the m in this? Y equals mx plus b. What's m?
Slope.
Right, but what is it? What number is it? No, it's the number in front of the x. It's 1, right? The slope is 1 over 1. 1 over 1. That's your slope. What's your b?
Plus 0.
Plus 0, right? So that's in y equals mx plus b format, right? But if I wrote it like this, if I wrote this, we meant now up here it was a straight line. This is a straight line, right? This is not a straight line. This is a parabola. Parabola. Right? And it looks like that right there. That
Wait.
drawing. Yes.
Okay. So, in like most algebra, like letters and stuff, why is like the most common things x and y?
It's a great question. It's not always. I mean, it is the
Well,
more.
it's-
It's
yeah,
the
it's
most.
like- yeah.
It's the most common that you'll see. Like in in the books, a lot of times they use lots of other variables as well. I just tend to not use them because I like my x and y since I'm comfortable with them. They're easy to write. It doesn't look like another number. Like the books love to use s, and when a student writes an s, it looks exactly like a 5.
That happened at my last school, and because my S's sometimes look like 5s, my grade got put down so much because
Yeah.
I hated it.
I know, it bothers me too. So like when I do an S, I have to write it very carefully, really accentuate the curves, I just don't like that. And a lowercase b looks just like a 6 when a student writes the b, right? And so things like that. Like an O would not be a great choice for a variable, right? 2O, right? 20, right?
Wait,
Things like
okay.
that.
Why is it also used on a graph for like the x, y?
X and Y. And because we're using these variables, they've chosen X and Y for the graph. But I could rewrite this. I could write m squared, I could write n equals m squared. And if I did that, then this would now be the n-axis, and this would be the m-axis. So it's based on what this is how you choose what your axes are called.
And the Z isn't a good choice either because then the C looks like an S, which looks like a 5.
Right. So when I do my Z's, I do that so that it doesn't look like a 2, because a Z can also look like a 2, right? But anyways, the X and Y's are so simple. There's no question. So I tend to use those a lot. It's a great question though. But the whole idea is make sure no matter what we do here, be sure you can also do it if I put an M in there instead of an X.
Oh, G is a good one, right, too.
T. T is a good one.
G.
Oh, G, yeah. And T is this. I usually put a little curly Q here when I do a T, right? We are going to be doing T's periodically. Okay. So we're going to be dealing with quadratic expressions, meaning they have an x squared in it. And we are going to learn how to factor them, okay? So before we actually factor, I'm going to actually put something up that's already factored, and we're going to get it out of factored form, and we're going to see what we do. So this is in factored form. This is a quadratic trinomial that doesn't look like a quadratic trinomial because it's in factored form. X plus 2 times x plus 3. So what process would you use to? What? FOIL, exactly. So my first, x times x squared, right? Outside, 3 times x, 3x, right? Inside, 2 times x, 2x. Notice I'm doing a plus here, Aiden, right? That's 3x plus 2x, and then plus 2 times 3 is 6. Now I'm going to combine my middle terms, boom. So I've got x squared plus 5x plus 6. Okay? Yes?
Since it's usually written like that, can you just add the numbers and then condense, and that would be the center piece?
Say it again. Say it one more time.
So you would add the last numbers in the foil, yeah.
And put it right here?
And just put max.
Exactly. That is true as long as your x's are all by themselves. It's not like a 2x or a 3x. They don't have a coefficient other than 1, right? Then that would work. Totally. Totally right on. That's a great little shortcut. So now, this is the quadratic trinomial. Why is it quadratic?
Because it has
It has the x squared. Right. Okay. Good. Now, the goal is, hopefully, in the next 8-9 minutes, you're going to learn how to go from here back to there.
Wait, didn't you
Because
do this?
this is factored form. This is this is the multiplied out form, right? So we're going to now learn how to factor
that's
a
so
quadratic trinomial, and it's really, really fun.
So we're factoring
It's
quadratic
really,
equations.
yes, you are, exactly. Well, it's not an equation yet because I didn't put an equal sign after it, or I didn't put an equal sign.
Oh,
An equation has an equal
expressions.
sign, an
And that
expression
gets more
doesn't.
complicated, doesn't it?
No, not really, just
No?
a little teeny bit. But once you get this is the hard part.
Is that going to be like
Once
next
I
lesson
put
or
an equal
something?
sign, once you know this, if I put an equal sign, piece of cake.
Is that going to be like next lecture or something?
It won't be next lecture, because we're gonna practice a bunch of these, because there's a few different formats of these, right? So I'm basically gonna give you, like, imagine a mechanic, or not a mechanic, like a carpenter. You know how he has a tool belt, with his hammer and his, tape measure and whatever. That's what I'm doing, is I'm giving you a bunch of tools for factoring. A ton of tools. You're gonna learn so many different things you can do for factoring.
Yeah, I have a friend who goes to St. Mike's and she says that it's so hard because they take so long because their teachers didn't teach them any kind of shortcut.
Yeah, you're
Or
going to learn a
anything like
lot
that.
of shortcuts with me. And your factoring is going to be so easy. When you walk out of here in 8th grade, you're going to know it. You could do it in your sleep. And the hardest part is after I give you all those tools for your tool belt, is knowing which tool to use when, right? And so we'll get into that. We'll be actually practicing those things, yeah.
At the end of the year, like next year, will we go over like everything?
Oh, yeah. Oh, yeah, for sure. Right now, we're doing that with the 8th grade, just to make sure, because they're going to be taking placement tests for their high school that they're going to. A bunch of them are. Yes?
Next year, are you teaching us or is Nate teaching us?
I will be, well, it'll probably be a combination of both of us. Because what we tried this year, which worked fairly well, is having a conceptual class and a regular class. The regular class being what I've always done, and the conceptual being for those who feel like they want one step further, they can go one step further, right? They
Who's
can go a little
teaching
bit
the
deeper.
conceptual?
And probably have Nate do that, because I'm really good at this. I'm good at what I do. And I know how to get people really ready. So that's usually that's how we did it this year. It's been going pretty well. But anyways, back to this. So we have to go from this to this. We have to factor this to get this. And there's a really cool trick. All right? So is this a quadratic trinomial?
Yeah.
Is there a number, a coefficient in front of the x squared? And is it 1? Okay. So those are my 3 requirements, or my 2 requirements. It's got to be a quadratic trinomial, and in front of the x squared is a 1 coefficient. Okay? All right? So when that's the case, I know I can try to factor it. So I'm going to immediately put my parentheses. All right? How could I get the x squared?
X.
Where would I put that in this to get x squared? You got to think of FOIL, okay? This times this has to equal this, right?
Up X.
X, right? So x is going to go here, and x is going to go there, right? Pretty straightforward so far, right? Right? That's the first part of FOIL. First is x times x is x squared. Yeah. Now the rest, there's this really cool little trick. What you want to do, this is your trick. And it's a really cool trick. So if I was going to write this, let me just do one real quick thing, because this will make it a little easier for me to describe what I'm talking about. I'm going to call this ax squared plus bx plus c. Okay? So a is your coefficient in front of the x squared. B is your coefficient in front of the x. You with me so far? Does it make sense? Just bear with me. And c is your number that has no x, right? Basically. So c is your 6. B is your 5, A is your 1. So I'm only dealing with things that are trinomials, quadratic trinomials, and A is 1. You with me right now? Okay, so this is the trick. This last number that does not have an x, I call that the C. Is that you with me? All right, so I'm going to say this. So you're looking for factors. Okay, well, fine. Let me put it this way. Find factors of C that add to B. All right, that is your trick. So think about it.
Oh,
I want to find factors of C, of my 6, that add up to 5. So I'm going to try it. Okay, that's easy. So 1 times 6. I'm going to put my factors over here, right? I've got 1 times 6. And yes! But wait. What's 1 plus 6?
7.
Oh, shoot. 1 plus 6 is 7. Uh-oh. And that's got to be a 5. That's not going to work. Oh, I know. We could do 6 times 1. Yes! 6 plus 1 is 7. Oh, shoot.
Isn't that the thing about factoring quadratic expressions is you have a bunch of series of different sets?
Yeah, you're gonna have to choose. So I actually recommend you write them out off to the side, and then just see, add them up and see what they get. You don't always have to write 1 plus 6 equals 7. You could just say 1 plus 6. You just sort of do it in your head, sort of equals 7. But the other one would be 2 times 3 is 6, right? And 2 plus 3 is 5. So when it's 5, then you realize, oh my God, we figured it out. So my factors of 6 that add to 5 are 2 and 3. So I'm going to put a 2 here. And is the 2 positive or negative?
Positive.
It's a positive. So I'm going to put positive 2. Right? And it becomes plus 2. Is it a positive 3 or or a negative 3?
Positive.
Positive 3. So I'm going to put positive 3, which becomes plus 3. Now, we're going to just double check. Always, 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 I'm not going to write it, always to the 5th degree, right? Always, 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 always. Right? Always check your work. And it's real easy. How would you check to see if you did it right?
If the answer in the beginning of the problem.
Yeah, so what process would you use to turn this back into this? FOIL. So first, x squared. X times x is x squared. Outside, 3x. Inside, 2x. 3x plus 2x is 5x. 2 times 3 is 6. We did it. Piece of cake, right? All right, so let's try a few. Does it make sense, you guys, so
Yeah,
far?
this is really cool.
Isn't it
I'm
cool?
a little bit confused.
Okay, well let's just do a bunch, and we'll just see if we can. So let's do x squared plus 2x plus 1. Okay? So immediately, is it a quadratic trinomial?
Yeah.
Yes, because it's x squared and there's 3 terms, right? And a is 1. A is 1. So immediately I can try to factor it. Right? Immediately. So I put up my parentheses. And I know right here, this and this have to be x. Right? Because x times x is x squared. That's easy. Now, I need to find factors of 1. Well, the only thing is 1 times 1, right? What is 1 plus 1?
2.
Yes! That's what I wanted. So, and notice they're both positive, right? 1 times 1 is positive 1. They're both positive, so I'm going to do plus 1 plus 1. And then I'm going to check it. First, x squared. Outside is 1x, inside is 1x. 1x plus 1x is 2x. Good. 1 times 1 is 1. Yes, it checks. All right, let's try another one. How about x squared plus 8x plus 15. Okay.
We need to find factors of 8, right?
So
factors of 15.
is it a trinomial we can try? Does it have a 1 in front of the x squared? Yes. So we can do it. So we'll quickly put our parentheses first, and then go ahead, Adam. What were we going to say? Factors of what?
15.
Okay, so sometimes what I do is this. I'll do 15, I'll put a circle around it, over off to the right, and I'll start figuring out what are my factors. Okay, 1 times 15. Let's see,
5 times
3
3.
times 5, and that looks like about it. What's 1 plus 15?
16.
16, right? That's not what I'm looking for. What's 3 plus 5?
8.
8, that's what I'm looking for. Those are my factors that I want. So I'm going to have x plus 3 plus 5.
These are fun
Aren't they fun? Yeah.
because they're pretty quick.
For any combination of numbers?
It always works when there are factors of this number that add to this. Sometimes there are not factors of this number that add to this.
And then,
But the ones I'm giving you for now all have answers.
but then
okay?
occasionally you're gonna give us
They're all factorable. Yes, great.
Wait,
Oh.
what about subtraction? What if it's like a negative?
So I have to show you one more thing. I'm sorry. I'll let you maybe. Just let me show you one more thing. What if I did one thing different? I'm going to use the same problem that we just did. Okay? Only I'm going to rewrite it. What if I did this? X squared minus 8x plus 15. Ooh. I've got to have factors of 15 that add up to negative 8. Well, what gives me a positive 15? There were actually more than I listed here. I could have also done negative 1 times negative 15 would have also given me a positive 15, right? What about negative 3 times negative 5? Wouldn't that also give me a positive 15? Wouldn't you agree with me? But what would this give me if I added them together? A negative 8. There we go. So now my factors are negative 3 and negative 5, right? So I'm going to just do my parentheses, my x's, and then I have negative 3, negative 5. Are you writing all this down, Henry?
What?
Are you writing all this down? You're going to need this, I guarantee you, for your homework. You're going to be so lost, it's going to take you forever if you don't write these things down. Okay, homework. So that's the end of the lecture for today. And you guys are